All right, so for this question, I wanted to do it separately because it's we're looking at, for A through E, inputting things into the function for values of x and looking to see what spits itself out as the output, or the y value, right? So input x, get out y. For question F, it's a little bit different because I'm looking for, when the two functions are equal to each other, what value of x allows that to happen. Okay, so what we're going to do, we're going to write down f of x is going to equal g of x, okay, and we're looking for the value of x. X that makes this happen. Okay, so this is probably the hardest part of this question, which is why of question 4, which is why I'm doing it as a separate video, makes this true. Okay, so what we're going to do, we're going to set the two equations equal to each other. We're going to have x squared plus 3x minus 5 has to equal 2x minus 3. Okay, so what we're going to do is we're going to pull on some of the skills that we reviewed at the beginning of the course, particularly around factoring and solving quadratics, to help us tackle this question. Okay, so what we need to do, in order to solve anything that looks like this, that has to be equal to 0 on the right side. Okay, so what we're going to do is we're going to shuffle things around. So I'm going to subtract 2x and add 3 and create the 0 pairs. And if I do that on the left, I have to do it on the right. So I'm going to take 2x away and I'm going to add 3 to the right as well, okay, or so to the left. And what I'm going to do now is I'm just going to rewrite the line with the like terms next to one another. And then we're going to see that we end up with a 0 on the right side. Okay, so what's going to happen here now is I can collect the like terms. X squared plus x minus 2 is going to equal 0. Okay, now we're going to solve this using our factoring skills, right? So I'm going to look for the values of x that make this statement true. Okay, and why we like this is we're going to solve for x, okay, by factoring. Okay, and what we're going to learn, or what we see here, is that this is a simple trinomial, right? Okay, and so we're going to factor it using our man method, right? We're looking for the two factors that multiply to -2 and add to 1. Okay, so we're looking for those two numbers. So 1 and 2 are going to be the two factors that I think end up working. We just need to assign a negative sign to force the addition to work out, right? So I think with the negative on the 1, -1 times 2 is going to be -2, and -1 plus 2 is going to be +1. So I think that checks out, right? And so what we're going to do now is just factor this, right? We know what to do. So this is going to be x minus 1 for a simple trinomial times x plus 2 is equal to 0. Okay, and what we're going to do is check if this bracket 0, then the whole thing's going to be 0. Okay, and so what we do to solve these kinds of questions is we say x minus 1 has to equal 0, and the same thing is true if x plus 2 is equal to 0. If that bracket is equal to 0, then 0 times the other bracket is going to set this left side equal right side. It's going to satisfy that. Okay, so what we see is x equals +1 and x equals -2. Okay, those should be the answers, or the values of x where the two functions will equal each other. Okay, and if we wanted to check that for sure, right? For instance, I'll just check one of them. So we should see, or maybe I'll do the check over here. Got more room. Okay, we should see when f of 1 should equal g of 1, and we're going to check that right now. Okay, so we're going to take the original equation. Okay, if you were ever had this on a test, you would you could check to see if your answers were correct by doing this, right? So the two functions again were x squared plus 3x minus 5 has to equal positive 2x, I'm looking at the wrong thing, 2x minus 3, okay? And what we're going to do is we're going to replace or substitute the value of x to be 1 in both equations, and we're going to see that the left side should equal the right side, right? So 1 squared plus 3 times 1 minus 5 has to equal 2 times 1 minus 3. So we get 1 plus 3 minus 5 has to equal 2 minus 3. Okay, so we get 4 minus 5 has to equal 2 minus 3. And if you look at that, negative 1 equals negative 1. So our check works out. Okay, when x equals 1, we set the functions or the values, the outputs of the functions are equal to one another. If we did the same thing with negative 2, we would see the same thing happen as this check work. Okay, so that's that.